let's give it a moment.
Oh, there we go. Yeah.
There you go. Cool. I'll keep quiet then. Over to you, Martin.
Yeah. All right. Thank you. So yeah, I guess first of all, thanks a lot everyone for taking some time out of your otherwise busy evenings, and thanks to the guys for giving me the opportunity to speak to you all tonight. So we're gonna go with a topic that's pretty pretty close to my heart, and something that I spend a lot of my professional time doing as well. And I'm going to take a slightly different angle to this. So we're going to talk about building a multi-tenant cloud native application. Obviously, scalability comes as part of that inherently, but we're just going to talk a little bit about what cloud native is. I might be teaching some people to suck eggs a little bit, so apologies for that. But I think it's important that we kind of level set what that term actually means, because there's a lot of different opinion of it, what it actually means. How does multi-tenancy differ from a standard application? We're going to talk about some of the considerations that they are to make within there. We're also going to talk about some of the architecture patterns as well for multi-tenancy. So again, I don't want to go down to the level of teaching people to suck eggs about writing code and writing microservices and writing APIs. And I'm sure all of you do parts of that or have done the elements of that. But what I want to talk about in this really is how you kind of bring it all together, and what are the different things that you might need to consider. If you're looking to do this at your organization, or you might have a side project where you might require something like this. And then what I want to wrap up with is, why DevOps is so critical when it comes to operating and managing and developing cloud native applications. And we'll talk about some of that stuff as we go through various different parts as well. Okay, so first off, what is cloud native? So there's a definition up here from the CNCF, the Cloud Native Computing Foundation. It's the one Microsoft used as well, coincidentally now as well. It did used to differ. But let's just go through it real quickly. So cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments, such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. So, what we're kind of saying here is that cloud native is all around speed and agility, and business systems are evolving from enabling business capabilities to really weapons of transformation. We've heard a lot about the transformation in the past few years since the pandemic. It's enabled businesses to do a lot. And really by enabling business capabilities and moving across to a transformation methodology and message, we're accelerating the velocity and growth of businesses by doing that. And really, from a business perspective, it's imperative to get new ideas to market immediately, especially where you have competition. At the same time, businesses are also increasingly complex, and users demand more, right? As our user base is getting more technically adept at what they do and what they use and how they use it, they expect responsiveness to be rapid, they expect features which are innovative, and they expect zero downtime. So things like performance problems, any recurring errors, the inability to move fast are things that are really kind of no longer accepted. And if you have those things within your application that you sell to customers, this is your business. If you have a SaaS model, your users are just going to start visiting your competitors. So cloud native systems are designed to really embrace that rapid change, scale, and that level of resilience. Okay, so just moving on, how does multi-tenancy differ? So first of all, we need to look at what multi-tenancy is. So multi-tenancy is the term we would use if we are talking about a platform that is used by multiple customers or tenants, right? Not multiple users, multiple customers, we will call a tenant. So by having numerous of those, we obviously get multiple tenants or multi-tenancy. So you may have hundreds of users from lots of different organizations, each with their own different configuration in your app or your offering. You may also have multiple users from a single organization or a single group to form a specific tenant. There's obviously other connotations of that as well. And then last but not least as well is, when building these multi-tenant solutions, there's quite a lot of elements we need to consider. And these are really critical, and I'm gonna go through these, and we're going to talk about these a little bit, and be interested in other people's feedback. In if you've done some of these, are there other things that you would consider, or have you considered the things that we're about to talk about? Because I do see these as pretty critical. So before you build or write any line of code, before you build any piece of infrastructure, you need to start asking these questions. So I guess the first one, and probably the most important, is how do you define what a tenant is for your solution? So for the most recent thing I've been working on, which is a cloud management portal for a managed service provider, a tenant is a customer. So multiple customers mean multiple tenants. And then another side of that as well is, how do we deploy infrastructure to support multi-tenancy? Again, various different ways to do that depending on the architecture pattern. And we're going to talk about architecture patterns in a little bit more detail soon. But think about how the infrastructure is deployed to support that. And it will be, like I say, very much dependent on the architecture pattern. But generally speaking, we're talking here about things like infrastructure as code and deploying that through pipelines. Any kind of tool that's available, be it Azure DevOps, GitHub Actions, anything like that. What pricing models are you going to offer, and how does that affect requirements? So, big thing with this is, and a lot of companies don't actually do this until they've already got something in service, which is the wrong way to do it. But your pricing model needs to reflect what you expect that customer or that tenant from a service or from a compute perspective. So if you have tenants which are likely to consume more because they're larger or they're more complex, then you need to be charging them a price that reflects that, so that you can scale the infrastructure to support their requirements. Otherwise, pretty much instantly, you're going to be making a net loss based on what you're spending to keep that customer going versus the compute power that they're actually consuming. Great example of this from an MSP's scenario would be things like crunching cost data that comes from Azure. Right? Cost data in Azure is massive. It takes up a huge amount of storage. The bigger the customer, the more subscriptions they have, the more data there is. So you need to make sure that in that scenario, you charge customers on a scale that affects your primary consumer of compute power, which in this case would be crunching those numbers on a daily basis. And so you create a pricing model that reflects the compute power that you need to do that, and that would scale based on the number of subscriptions that the customer onboards to your solution. Obviously, depending on the solution and depending on what the primary method of producing the data or producing results would depend on what factors you need to increase. What level of service do you need to provide? Again, right? What do we mean by this? It could be that you have a dedicated account manager for your very large customers, all the way down to providing them with to raise a number of tickets to get assistance with something that they're having an issue with. But you need to define what those service plans look like and those services look like. And again, make sure your pricing reflects the effort that you would have to put into providing that level of service. Next one is, how do you plan to grow the business or the solution? So this isn't just an basic plan around producing a business plan. It's not particularly around marketing, although that obviously is part of it. This is from a technical perspective. how does your solution scale? How do you add the resources you need to make it scale based on the plans that you're producing? And next one is around tenants with unusual requirements. How do you deal with them? It could be that you're writing a SaaS solution, you're trying to make it as generic as possible, but how do you deal with any unusual requirements that come in? Are those requirements actually unusual and it's just that you've not thought about them? And it could be that a lot of clients have those requirements. So those are things to think about as well, and think about how you're going to deal with them. Do you service them as a fee? So for instance, we would do custom development on our platform, but we would potentially charge our customers for any additional work over and above that would take up sprint time or development time based on how useful it was to the rest of the customer base. If they've come up with an idea or a function that's going to benefit every customer, then we probably just do it as part of our normal development cycle. But if it's something that just benefits them, you need to balance out the effect it has on the rest of the work you have in your backlog versus the benefit it's going to give everyone else. Second to last, probably a really important one as well, is how do you secure, manage, monitor, automate, scale, and govern your environment? So many times I've been to customers that I've worked with or organizations that I've gone in to start doing some of this stuff, and something's already running, something's already servicing clients, but there's not been the thought around how do we monitor it? How do we know if it's working properly? How do we know if the customer has a problem? How do we automate the deployment of it? How do we govern it from a policy perspective? How do we make sure data stays where it needs to? How do we scale it in case people start putting more data through our platform? And how do you manage it as well? These are all things that you need to be thinking about before you build in anything. And then last but not least, and probably one that catches most people out, is think about quotas and limits in Azure. So especially if you're deploying on Azure, obviously, but it would be the same for AWS. It would be the same for GCP. It would even be the same for a private data center as well. You would only get so many resources, but especially in the public cloud, are resource quotas and limits on functionality based on the service tier you've picked for a particular component going to limit your ability to scale or limit your ability to service customers? So think about the effect of those and think about how that can affect your particular design. Okay, so moving on to architecture patterns. So there's quite a lot to go through. So we're going to talk about 6, I think there is in here, and these are the most common ones. So first up is logical and physical tenants. So once you've determined what the tenant means for your particular solution and whether you should distinguish between logical and physical tenants, this is something that might come into play. So, great example, consider something like Spotify or some kind of streaming service. So initially, that might be built as a solution that can cope with thousands or, maybe even tens of thousands of users. But as you continue to grow, you need to duplicate the solution or some of the components in order to scale to meet new demand. So that means that you'll need to work out how to assign specific customers to specific instances of the solution. You might do that randomly, you might do it geographically, you might do it by filling up a single instance and spilling over into the next one. However, at some point, you will probably need to maintain a record of which customers you have and which infrastructure their data and applications are available on, so that then you can route traffic to the correct infrastructure. So in that example, you might represent each user as a separate logical tenant and then map users to physical tenants that represent those different instances. So in that scenario, you have a one-to-many mapping between logical and physical, and you can move between them at your own discretion. In contrast, think about a company that builds cloud software for law firms. Customers might insist on their own dedicated infrastructure to maintain compliance. So that's another thing that you really need to think about there. So in this example, a logical and a physical tenant are really the same thing. The key difference between a logical and a physical tenant is really how the isolation is enforced. So when you have multiple logical tenants sharing a single set of infrastructure, you're relying on the code and a tenant identifier in a database, for instance, to keep the tenant's data separate. When you have physical tenants, they have their own infrastructure. So it may be less important for the code to be aware that it's operating in a multi-tenant environment. Sometimes you'll see physical tenants referred to as something like super tenants. We also sometimes use deployments or stamps as a terminology as well. But these are ones that are, I guess, kind of really common that we see in the industry, and certainly see a lot of these when talking to customers as well. It's important as well to, when you think about logical and physical tenants, to think about the effect of data leak. We talked about some of the differences and how your code might be aware of that. But also noisy neighbor effect as well, especially on latent sensitive components like databases. If someone's running a long query over here, does other operations affect that? That's called noisy neighbor. So next is around tenant isolation as a whole. So rather than thinking of isolation as being a discrete property of I guess, the overall solution, and you can also think about isolation being a continuum as well as being a component level thing. So you can then deploy components of your architecture that are more or less isolated than other components in the same architecture, depending on what the requirements are. So from a security perspective, if you're sharing infrastructure between multiple tenants, you need to be really careful that you don't access data from one tenant to another and return responses from another one. You need a strong foundation of identity. So, consider using what's already there. Don't go reinvent the wheel. Use something like Azure B2C, Azure AD if appropriate, anything like that. And you consider both tenant and user identity within the authorization process. The user belongs to a tenant, so you need to ensure that they're accessing the right thing and that they're able to access the right thing. And from a cost perspective, pretty simple, right? Shared infrastructure that is used by multiple tenants is cheaper. Unless you're deploying one-to-one, if you're deploying one-to-many, it is fundamentally cheaper. From a performance perspective, again, if you're scaling up, if you're sharing that infrastructure, the performance may suffer as more customers use it, since its resources may be consumed faster. So again, noisy neighbor syndrome is a thing that you need to think about on that as well. From a reliability perspective, again, single set of shared infrastructure, one person could cause a problem that affects everyone on that platform. So you need to think about how that works as well, and how that affects the overall responsiveness as well. Because when you deploy infrastructure that is dedicated to a tenant, you may be able to tune that config for the specific requirements, but if it's a shared model, if it's a fully shared model, you obviously can't do that. So there's definitely things to think about in there. Okay, so moving on to automated single tenant deployments, right? So, automation is really the key thing. So, I kind of will say here that where this slide mentions automation, but others don't, right from the outset, you need a method of being able to deploy this stuff automatically in a repeatable fashion so that you can update and manage them a lot easier in the future. But we'll talk about that a little bit in the future. Excuse me. So, in this scenario, so for our single tenant deployments, our application is responsible for the, I guess, coordination of the deployment of the tenant's resources. So typically you might be building something using a model that makes use of infrastructure as code. And if you're building in Azure, you'd be using the Resource Manager APIs as well. You might use this approach when you need to provision entirely separate infrastructure stamps. So remember that pattern we talked about earlier. Some of the benefits of this model. So I guess the key one of this approach is that your data for each tenant is completely isolated. So that completely reduces the risk of accidental leak, because if you're tenant A, you go to the web app that's responsible for tenant A, that talks to the database that's part of tenant A as well, and you can't, go between the two. So that's a key one. Especially with customers with a regulatory overhead as well. They're going to look for assurances that you can't leak data between clients, and they're going to look for you to show how you're managing that within your application as well, especially in tenders that you might be doing as well. Tenants are also unlikely to affect each other's performance. We talked about noisy neighbor syndrome a little bit. In this model, unless you're sharing underlying resources from a compute perspective or from a web app perspective in Azure, you might be using the same app service plan. If you're using separate ones, it's obviously unlikely to be a performance bleed across the different tenants. And updates and changes can be rolled out progressively using this model as well across the different tenants, which would reduce your likelihood of a system-wide outing. So, some kind of things to think about there. From a risk perspective, right, there are risks with this approach. Right, the cost efficiency is almost non-existent because you aren't sharing any infrastructure between your clients. If a single tenant requires spending a certain amount on infrastructure, then it's likely that 100 tenants will require 100 times that cost and expenditure. So any ongoing maintenance as well, things like new configs, updates to patches is likely to be really time consuming. So any operational processes around this have to be automated, otherwise it just won't work. Otherwise, if you want to keep up with the pace at which we deploy software today, obviously most of us that write software, we probably work in an agile manner and we look to release as soon as possible, basically. You are going to end up with a scenario in this model quite quickly where you're constantly chasing your tail to update various different parts of the software. So likewise, ensure you plan as well for how you can query and manipulate data across multiple deployments. And from an admin perspective, if you need to update your tenant databases, how do you do that efficiently without running a query on every single database? There's something to think about there. So just before we move on, I've just seen a couple of questions come in. So yes, absolutely, the slides can be shared. We can do that, no problem. And then Richard asks a question here. So with the dedicated deployments, each tenant having their own database, do you have any experience that compares the performance resource requirements of individual databases versus everyone in one DB with a tenant key in every table? So let me come on to that in a second, because there is something I was going to talk about that kind of covers that, and I can talk about my own experiences of the platform portal that I've built more recently, which may answer that. So if I don't, please remind me of that shortly, and we can talk about it a bit more. So in this scenario here, we're talking about fully multi-tenanted deployments. So this is where everything is shared. So this is the opposite extreme of what we've been talking about. So obviously from a benefits perspective, just kind of replaying what we've talked about before, this model is really attractive because we have lower costs. So we can operate the solution with shared components. We can deploy higher tiers or higher SKUs of resources. It's still often the case, though, I guess, that more overall deployment cost is lower than a set of single tenant resources. And if a user or a tenant needs to move their data to another logical tenant, you don't have to migrate data between separate deployments. Risks of this, though, we've obviously got to take care that we deal with separation, tenant separation, and don't leak data between tenants. We need to manage sharding of data ourselves as well, depending on how that's done. Additionally, we may also be concerned about the effects that individual tenants have on the overall system or performance of other tenants. So again, using an example from earlier, if a single tenant is trying to perform a real heavy query or operation, how does that affect other tenants? This is where your monitoring comes in to kind of make sure that you're, really on top of what's happening. Okay, another risk as well is how do we track and associate the costs for each tenant if the cost is important to you to track as well, that is. So maintenance can be a lot simpler with a single deployment since you only have, I guess, to update one set of resources. That's often riskier though, since any change might affect everyone, obviously. And then scale might be a factor in this as well. The more likely, you are more likely rather in this scenario to reach scaling limits in Azure when you have a shared set of infrastructure. For instance, great example, happens all the time, storage accounts. Despite your solution, as your scale increases, the number of requests to that storage account could reach a limit of what the storage account can handle. So to avoid hitting resource quota limits, you may consider deploying multiple instances of the same resource. Or you might even consider distributing your tenants across different resources if you've deployed into multiple Azure subscriptions. So I'm just going to finish off a couple of slides, and I'll come on to a couple of other questions that have been coming in as well. So next one is around horizontally. No, it's not. Sorry, vertically partitioned deployments. Reading the wrong notes. So again, this scenario is really like, I guess, a combination of both. We just talked about extreme ends of the scale, so where you have everything shared versus everything separate. But you obviously don't have to sit at the extremes of those scales. You can consider vertical partitioning. It's quite easily done, to be honest. So you can use a combination of single tenant and multi-tenant deployments. So for example, most of your customers' data and the application tier would be on multi-tenant infrastructure, but you might deploy single tenant infrastructure for customers that require higher performance or data isolation, thus are going to pay you more ultimately. So going back to that that we talked about earlier around thinking about your payment plans, here, if you're giving people the option to have better performance or better data isolation, what we're talking about there is having people pay you more for the service. So definitely don't forget that, because it's going to cost you more to run. You could also deploy multiple instances of the solution geographically and have each tenant pinned to a specific deployment. So that's really effective when you have tenants in different geographies, if you're a global customer, for instance. Some of the benefits of doing this, obviously, you are still sharing infrastructure to a degree, so you can still gain some cost benefits of having shared resources. You can deploy cheaper resources for certain customers, like those who are on a trial, for instance, or on a lower level of service. You can build customers at higher rates to be on single tenant deployments, like we've already said, and thereby recouping some of your costs. So this is where the cost kind of side of it really comes into it, depending on what you're giving people access to and the power from a compute perspective that they have access to based on the level of service they've signed up for. What does that infrastructure look like? From a risk perspective, okay, so from a code-based perspective, your code has to support both multi-tenant and single-tenant deployments. So you obviously need to think about what that would look like from a code perspective. If you allow a migration between service tiers, how would you migrate a customer from a multi-tenant environment to their own environment, and vice versa as well? You also need a really clear understanding of which of your logical tenants are on what sets of physical infrastructure, so that you can communicate information about system updates, system issues, upgrades to various different customers. So there's a few different ways that can look, and a few different ways that can work. So, a few things to think about there. And then finally, in here, just before we come on to some questions, is horizontally partitioned deployments. So, in here, we can also consider this as a deployment methodology. So we can have some shared components and maintain other components within a single tenant deployment. So for example, you could build a single application tier and then deploy individual databases for each tenant. From a benefits perspective, when you do it horizontally and partition that way, you can help mitigate noisy neighbor problem. Noisy neighbor syndrome, sorry. So if you've identified that most of the load on your system is due to database operations, for instance, you could deploy those specific database components separately for each tenant. So, that's generally a good way to do it. So if a single tenant also sends a large number of requests to the solution, again, thinking about databases, the performance of the database might be negatively affected. But just for them, and other tenants' databases and other shared components would remain, relatively unaffected. The risk we want of this as well is, we still need to think about the automated deployment scenario. We still need to think about the management of components, and especially the components being used by a single tenant. So let's just go back up a second. So just going back to Richard's question, first of all, which we very briefly touched on, is around dedicated deployments and each tenant having their own database. And it was, do you have any experience that compares the performance and resource requirements of individual databases versus everyone in one DB with a tenant key in every table? So I guess my initial answer to that would be it depends what the application is doing, and it depends on the general requirements of the customer. So the reason I say that is from an MSP perspective, when writing a cloud management portal, separation of data is really important. We don't want customers to even think about having the ability to mistakenly see someone else's data. But we also need to think about cost, especially given as an MSP, we might give this product away to some customers and give some features away in there as well. So most of my experience from here would be the horizontal partition deployments that we've just talked about, where, for instance, all of our microservices and our front end are all hosted as containers on AKS. And we have a catalog or a core database which stores all of the tenant information in. And then we have a database, which is the tenant ID, which is named the tenant ID, which stores that information separately on a per tenant level. So the way we would do that in Azure is we would use an elastic pool. That'd be a good way to do it in a cost-effective way. You wouldn't mitigate noisy neighbor syndrome in that scenario though, because the elastic pool is shared between all of the databases that you have deployed. Again, if you were going to charge them more, you could move them onto a separate database and their own dedicated database and mitigate that problem. And we did that for some customers, but for the most part, these are done specifically in a shared infrastructure environment. So they're all on one elastic pool, so they're physically sharing the same underlying resources, but they have a level of separation because their tenant data is stored in their own database. Now, if you wanted to be even more cost effective, you could do the second part of what Richard's mentioned there, which is everyone in one database and a tenant key in every table. And there's nothing wrong with that approach. You just need to think about, how that meets any potential regulatory issues you may come across. You may also want to think about anything to do with how your application mitigates the fact that tenant one needs to only be able to access tenant one's data and not tenant two. There's lots of different ways to do that. So how we did it was twofold. So first, accessing the APIs is an authentication and an authorization process using Azure AD, using secrets from an app registration. I can't think of the word then. And using the app registration, we obviously, a multi-tenanted app registration, we're registering a client's directory and we grant access through there. And then we pass in the tenant ID as a header to the request and the authentication token. We know we're authorized. We do the validation in the API to make sure that we're authenticated and that we're authorized and that the access token is valid. And then we validate that the tenant ID that they're passing across is the same as the one in the access token. If there's a mismatch, obviously we send back a 403 error, but we match up that yes, the tenant ID they're trying to request data from is the same as what they have in the access token. We'll allow this request. And when we make the connection request and database, we are doing manipulation of the connection string to go look at that particular tenant ID and go connect to the specific database. And we do that just by having a standard string in Key Vault, and it has a replacement variable in there, and we replace it when we go connect. This is really efficient, really works from a performance perspective. And would it be quicker going to every tenant in one database? Yeah, absolutely would be, and it definitely would be cheaper because we could have one database, we could have one pool to look at of resources, but a key requirement for us in this scenario, and a key requirement for lots of organizations, would be that data security and that data segregation. So we need to try and think about it from that perspective, and think about what's the most. So just moving on to what Mohammed has asked here is, do you recommend having one generic solution and for every tenant to have its customization, in case you have different business requirements per tenant but one product? So, again, I think I've seen a point in a bit further down about it being very much dependent on the product. That's absolutely right, and it's the same for this. What options you give your customers as part of your product from a customization perspective is obviously up to you, but you need to consider and I guess think about how much that might affect the complexity of your application. So absolutely, right, you could have different businesses with different business requirements per tenant and one product. You'd have to think about how you manage that, how you develop that, how you put updates into that, and what complexities that might have. Personally, I would stay away from stuff like that. SaaS, software as a service, the model is, if you fit this customer profile, then you can use our product. If not, then we're going to say no, and that's a call that you're going to obviously have to make as a business. So next question we've got here is, when starting a new multi-tenant project, is a pragmatic approach to begin with logical tenants, shared infrastructure, over physical tenants? Okay, so yeah, good question. And again, it depends, right? So it depends on your requirements. It depends on your customers' requirements. The target customer that you're looking at, they may be more sensitive to security and data residency, which would force you down a different route potentially. But again, you have to think about how your application is going to evolve over time as well. So if you start out with a shared infrastructure, you would need to think about how you would migrate that to a physical approach in the future, if that's an approach that you wanted to take. As with most things in software engineering, and as with most things in infrastructure, the answer's possibly yes. It could be pragmatic, but it really depends on the requirements. And then Arctic's really hit the nail on the head there, which is why cost is so important to this. Is it purely depends on the product being offered and how much the client's willing to pay. Absolutely, it does, and that's a call you need to make, managing and building the product. is, if you know that you have a great set of features and you have some clients may even benefit from a fully isolated deployment of that, then that is fine. And they might want their own separate deployment. But again, an SME, as Kartik points out there, might prefer a shared deployment. And again, that is also absolutely fine. So it very much does depend on the product. It very much depends on the client, and it very much depends on what problem you're trying to solve with your products as well. Mohammed asked another question here. If the application is monolithic, so how the development model will be if it's monolithic. So that's a tricky one, right? Because obviously you need to think about, if it's a monolithic product, it's obviously a lot harder to implement some of these things. But just going back to this example, for instance, a single tenant deployment, if it's monolithic on a VM, for instance, then there's nothing to stop you deploying a VM per client if that's what you want to do, and if that's the way it works. Some of these, and a lot of these, do apply to monolithic applications still. I guess the key thing really is what it boils down to is, are you prepared to put the time in to not make that a monolithic application anymore? There's a huge amount of work involved in moving from a monolithic application to a cloud native and microservice based app that we're traditionally talking about for this approach here. But that's not to say that it can't be done. It absolutely can be done. But there are some things that you can do with that approach, and there are some things that you can't do. And again, it all depends what the product is, what the application is, and if it can be split up from a monolithic application. The key thing, I guess, with the kind of point of the whole talk here is, when we're building cloud native apps and we're building them with multi-tenancy and scalability in mind, all of these solutions lend themselves to that particular deployment model and development model. Monolithic, it doesn't, but as I just say, right, you could do this deployment model that's on screen now with VMs or web apps that are running monolithic apps, equally as well as you could if you were running a backend on AKS with microservices. So again, kind of the default answer for a lot of these, but it does depend on your requirements, is the honest answer. So yeah, some good questions. So keep some of them coming if anyone has any questions. So just to wrap up then, so why must you practice DevOps for some of this? So we've talked about a few kind of different topics going throughout some of these bits and pieces, but I kind of want to highlight, especially from a cloud native perspective, a monolithic application wouldn't really apply to some of these, but certainly from a cloud native application and a microservice based app, I genuinely believe that unless you are practicing some DevOps methodologies, you are not going to perform as well as your competitors who are most likely already doing this kind of stuff. So, just a quick recap here on how DevOps actually helps. So, there's obviously a load of benefits to DevOps, but I've tried to pick, business related ones in this as well. So, deployment frequency, really big one. We talked about keeping up with your competitors. If you can deploy more often, if you can take your business problems or your customers' business problems in your product and develop new processes and systems more rapidly using strategies that DevOps teaching us, you make your business more efficient. You realize your ideas quicker than your competitors, and that gives you edge in your market. So, there's a lot of the processes within DevOps and a lot of the systems that we use that enable that to happen for us and enable it to happen well with time. Key thing to remember with all of this is it doesn't happen overnight. I've been to talked to various different customers now where they're very much of the opinion, we've been doing DevOps for 4 weeks and it's not making a difference. It's like, well, you kind of, first of all, you're not doing DevOps, but you're practicing elements of DevOps, but you need to stick at it and you need to gain some of the continuous improvement and continuous feedback cycles that come with DevOps to see incremental improvements in what you're doing. Customer experience or improved customer experience, really big one, right? When you're developing your solutions to better suit your customers, some studies have shown that over 70% of businesses report improved customer experience when they've implemented DevOps. And that's in the State of DevOps report from last year. So most organizations that implement DevOps see improved customer experience. And if software as a service is your product, customer experience is vital to how you operate as a business. So you need to think about what this looks like and how this works going forward in the future as well. Better morale, right? This seems like a really odd one to add in, but when you improve collaboration, you communicate better as a team, and ownership of all the different key components is shared across multiple different teams. When people work together well, they're happier at work as well. So, there's a kind of a side effect there of doing this improvement in collaboration and communication that we get with DevOps, in that we make employees happier. Okay, so last couple of bits, more time for innovation, right? We say if we're not firefighting, if we're not able to, if we're not focusing on today, and we're able to leave more time for developing our new ideas, thinking about the future and innovating, that helps our business grow, and it also helps our business succeed as well, because we're able to keep in front of our competitors. If you're an organization that is constantly firefighting, and if you're an organization that is constantly thinking about what's going to break today, what's going to break tomorrow, this incident happened last week, it's still going on, then you don't have time to innovate. It's a simple matter of fact. It also gives us better problem solving abilities, or faster problem solving abilities. So process problems cost businesses money, and fundamentally an application goes down, the longer it takes to fix a problem, the more money the business loses. If you're a SaaS business and your product is down, you are not making money, and people are complaining, and if you don't fix it fast enough, they will go to your competitors. As we talked about right at the top of the talk, right? Today, people expect more, right? And that is down to people being more tech savvy using these products. They expect them to work flawlessly with no latency. They don't like downtime. They don't understand why downtime happens, and they will quickly move on to something else. And that's kind of been exasperated a bit by, I would say, just the element of SaaS. Like the fact that if you get bored with a SaaS product, so you can just leave it and go on to something else, and it will just stay there. And you don't need to uninstall software. You don't need to offboard it from your network, all of those kind of things, like we would if we deployed something on a server. And we can just leave it and no one's any the wiser. So it needs to be right, and it needs to work well. So when we use the processes through DevOps to help us fix problems, understand those problems and fix them faster in the future, we can stop losing as much money from outages, and we can keep customers happier by being as transparent as possible, which is one of the things that DevOps also helps with when it talks about ownership. And then, finally, I just want to mention SRE, or site reliability engineering, because this is one of my bugbears in the industry. So, SRE, or site reliability engineering, however you want to pronounce it, is really an engineering approach to IT ops. It's a software approach to IT ops. So our SRE teams are using software as a tool to manage our systems, solve problems, and automate tasks. So SRE takes the tasks that we would historically have done by an operations team, generally manually, and instead gives them to engineers or operations teams who use software and automation to solve problems and manage production systems. Right? SRE is, a valuable practice really when creating scalable and reliable systems. It helps you manage those large systems from code. And that in itself is more scalable, sustainable for sysadmins managing thousands or hundreds of thousands of systems or platforms. The concept of SRE obviously comes from Google. I'm sure most people know that. And a guy called Ben Sloss is the guy that's credited with SRE. And it really tries to help teams find a balance between releasing new features and making sure that they're viable for users. So that should be what the key kind of takeaway is from my perspective on SRE. It doesn't replace DevOps. Standardization, automation, they're two really important components of SRE. And engineers should always be looking for ways to enhance and automate operational tasks. And in that way, SRE helps improve the reliability of the system that we have today. So also improving it as it grows over time. So SRE really helps teams who are moving from that traditional approach to IT operations to a cloud native approach. And I've seen organizations that are trying to treat a cloud native approach like a traditional set of IT operations, and they get into a real mess quite quickly. And this methodology around SRE and the practice around SRE can help you with that. So I guess fundamentally, DevOps is the approach to culture, automation, platform design, and increasing business value. And SRE can then be considered an implementation of DevOps because it goes to address a lot of those things rather than it being something that DevOps is or isn't. So yeah, multiple different ways to kind of think and deal with those things. And again, like we've talked about a couple of today, it is different depending on what your application is doing, how it's doing it, and what you're trying to achieve. So definitely things to think about there. So I've seen a couple of other questions come in, so I'll answer those in a second. But I guess first of all, I just want to say thank you for listening. Appreciate that's quite a presentation heavy talk that talks about a lot of different things and isn't much practical in there. So thanks for staying with me on that. This is all based on stuff that I've done for organizations or with organizations. So there is no theory per se in this. Is all stuff that we've done and works well. So just a good way to share some information. Okay, so let's have a look at questions here. So Michael says, a full multi-tenant deployment using a SQL Server DB, would using global query filters be a reasonable approach for implementing the tenant ID in each table? So we don't have to modify each query to check the tenant ID. I gotta think. So I guess yes, it would, is the honest answer. So yeah, I get it. So it's part of an entity framework, right? So yeah, a common application of this would be, I guess, what you just said there. So we've talked about multi-tenancy, that would definitely work. So when you do that, the entity type would define a tenant ID property. Another good way that you can implement something like this as well in or using global query filters is soft delete. So I think that's a good use case for global query filters as well. But yeah, Michael, yeah, you're absolutely right there in that. This would be a way to, if you're using EF, that is, And this would be a great way to implement multi-tenancy across or multi-tenancy behaviors, should we say, across your models. So yeah, absolutely, that would be a great way to do it. And I think I could be mistaken, but I think there's a really good GitHub sample I've seen before as to how that works. Just while we're finishing up chatting here, I'll see if I can find it and put it into the chat here so you can see it. And then Nick asks here, what would you recommend to manage user authentication with regards to multi-tenancy? So again, I will go back to it depends what you're trying to achieve. So in the scenarios that I've talked about here, where we have managed service clients as part of being a managed service provider, they all have an Azure tenancy. So they all have Azure AD. So that's the natural kind of place for that to happen and for that to take place. Also, as well, given that we're accessing the Azure APIs using our backend microservices, then the app registration scenario using OAuth within Azure AD works really well. And we don't have to write any of the code to do that. It's all managed within the .NET framework itself. So works really well for us. That said, right, if you're taking external users or external tenants, then I guess any kind of framework would work well. You can also use something like Azure B2C. And if you wanted to take Facebook, Google, or Twitter logins and stuff like that, you could use Azure B2C, and again, that works natively within a .NET backend from a multi-tenancy perspective. But again, kind of linked through to what Michael said. If you're using SQL Server as a backend or storing user details in there, then the tenant ID is really critical of making sure that you have a table that stores your tenants and a user that stores your users and what tenant they're affinited to. Another scenario that we've not talked about actually on authentication is you need to think about if a user can have access to multiple tenants. While it's an edge use case, I have seen it in some applications. So I don't know if anyone uses LaunchDarkly and a feature management tool, but you can have access, your account can have access to multiple different tenants. I'm not sure how they implement it. I've never needed to implement that myself. So I can't off the top of my head provide any kind of quick guidance on how you might achieve that, but it's certainly something that you'd want to think about in your use cases early on, is as well as supporting authentication from a user to a tenant, does that user need to have the ability to log into multiple tenants as well? So that's one thing that I would think about. I have just found the link here, so to Michael's thing there with a link to it. So yeah, that's all of the. I think that's all of the questions. So yeah, that's all of the questions. Michael's just something in. Where are we?
So if anybody does have any more questions, feel free to say them out loud as well.
So Michael's got on here. I have a SaaS app that uses .NET Razor Pages with Microsoft Identity. You mentioned Azure AD, Azure B2C. What are the benefits to using Azure? So I guess from an auth perspective, so from an Azure AD perspective, single sign-on is definitely the biggest one on there. So if you're working with organizational accounts, rather than normal logins, which is where B2C comes in, and you might be using Microsoft accounts and those kind of things, or Google accounts. If you're using Azure AD and you're talking to different organizations and working with different organizations, it's a proper single sign-on scenario. You don't have to manage the authentication for your app. You have completely offloaded it to your customer. They decide who has access to your app. They disable that person's account. They can't access your app anymore. So that's one benefit, because you don't have to manage any of that at all. Sort of the same with B2C, really. You don't have to manage that whole scenario around login flow, registration flow, that's all managed by B2C. And you don't have to store any of that information. B2C takes care of that for you and just passes you the fact that they are authenticated, and you can validate that in your code. So those are the key benefits of really, right? Authentication and authorization are basic things, but when people start to manage and implement them themselves, I tend to find that people can, I'm not saying you have here, Michael, in any way, but people can make a mess of it and get themselves in a twist with it quite quickly. And don't forget, you have to manage the ability to reset people's passwords, remove accounts, all of that kind of stuff. Whereas if you use in B2C, you just pass a request on, or if you're using Azure AD, you just tell them where tenant ID is and the access, the authorization and authentication is all managed there. So that works pretty well. So yeah, absolutely. So yeah, comment there on Postgres based database called MyTenDB. It does handle tenants pretty well. Excuse me. In fact, it handles it better than most things I've seen. To be honest, it does work really well. I've not given it a try in a production environment, I'll be honest, but I have read people have some scalability issues with it, so I'm not sure what happens there, because Postgres obviously scales pretty well generally anyway, so I'm not sure what's happened on there. But again, with anything, like with anything else, there's different options available. We use SQL in our solution here, but I've also used MySQL before for whatever the requirements were, and all sorts of stuff. One of the things I will kind of mention, actually, just really quickly, back on SQL and back on Michael's point about query filters using EF, is when you define the tenant ID, it has to be, instead of being public, it has to be declared as private, I believe. So obviously, kind of standard naming convention. Definitely don't want to get into the arguments of whether we use underscore or whether we don't, or whatever for the declaration of that property. But I believe it's private, not public, that you declare it as. So just something to be aware of there. But yeah, you can quite easily use the EF API then to go across to that entity and match up your tenant IDs quite easily. So yeah, it's a good way to do it if you're using EF Core, definitely. Okay, does anyone have any questions they want to ask that are not in the chat? I'm just going to go back here, actually, when I figure out where this is to the beginning. So if you're a Twitter user and you kind of think of something tomorrow, later in the week, whatever, or you watch the recording back, there's my Twitter handle there. Feel free to connect with us on there and give us a shout, or find us up on LinkedIn as well, yeah, if you have any questions later, please feel free. Please feel free to reach out and ask any questions there. I've seen something come in as well. Mohammed's asked a question. Do you recommend using Event Bus to share tenant ID? So I guess, again, depends on the requirements, I guess, is the honest answer. But it's a payload at the end of the day, so it kind of depends how you want to share that data and what the goal of using Event Bus as event middleware is. But yeah, there's nothing wrong with that as long as it meets the requirements that you're trying to achieve, I guess, is the ultimate thing. It's a bit difficult to say definitively whether you would or you wouldn't. It really does depend on what you're building and what you're trying to achieve. Cool. If anyone has any other questions, again, feel free to off mute. Otherwise, yeah, thanks very much for your time, everyone, and thanks for the questions. Thanks again for the group for having me, and yeah, fingers crossed next time can be in person.
Awesome. Thank you very much.
Thank you.
I'll stop the YouTube recording now, unless anybody speak now, forever hold your peace. Another question.